Today on This Old House,
This new deck is going over the rubber roof and the sleepers with the help of this tool and these clips.
How do we zone a house that we've pulled apart? I'll show you.
and it's up on the rooftop with solar panels. Hi there, I'm Kevin O'Connor, and welcome back to This Old House and to our cape built in the 1880s. So the big development for us this week is that our walls are finally getting insulated, and that means that our electricians, our plumbers, and our HVAC crews have got all of their work into the walls. The other big news is that we are getting ready to finally take a delivery on our windows, so maybe we can get some heat in here. And Tommy and Charlie are out here on this side deck area. And you guys are getting ready to put down the final top deck there, right?
We are.
Tommy, what are we, Charlie, you know it's like 30 degrees out, right? You get your jacket?
I got 2 layers.
You got 3, actually. What are we using for material?
Well, this is a material that we've used before. It's a composite decking. But the interesting thing about this, it's actually, if you think about the interior, the composite makeup of this, think of it as fine particulates of sawdust that are encapsulated with plastic.
Huh.
The benefit to that is moisture will not affect it. So you can install this on the ground, under the ground, and even in the water.
Wow, all right. Ooh, that's dense too.
Yeah, it's dense, it's
Okay.
heavy, but it's impervious. It doesn't take any water at all. Yeah.
Okay, and it's got slots on both sides, so not tongue and groove.
Right, it's hidden fasteners, so you don't see anything through the surface. So here's one of the clips that we'll use right here, and this one just goes into the slot, and the other side of the slot of the other board will go into there, and it holds the 2 boards down when you screw it, and you don't see the fastening system.
Okay, sounds good. And in terms of what's below, Charlie, we've got living space below this deck, so you had to make this watertight.
Yeah, it's just like a regular roof system, really, of a house, but we're going to have a deck above it.
Right.
So we installed a rubber roof over it. The actual frame has a pitch to it, about 3¼ inches from front to back. So we had to level the deck, so we put a sleeper system on.
Gotcha.
And we determined the thickness of our start of our sleeper on our screw, so it doesn't go into the rubber roof.
Ah.
So our clip system goes down into the framing and it gets screwed in, but we don't want to penetrate the roof.
Gotcha. Okay, so sleeper is in.
The sleepers are in. You know where its sleeper came from?
Like these? No, I don't actually. Wasn't expecting the quiz, but
Well, years ago, they used sleepers in roads with horse and carriages, and it was basically they would take the timbers and they would lay it on the road and they would infill them, and that would give a path for the horse and carriages to go.
Okay.
But then the builders started using them. They would take logs and they would put a perimeter out for what we call a sill of a house.
Yeah.
And then they would put the timbers on top of that and frame the house.
So anytime they laid the wood down, lay it down, hence sleeper.
Right.
Okay.
So these are sleepers on this roof, which basically takes the pitch off of the roof that's down below for the water to shed, but levels the deck up top.
Professor Silver, can we get to work now? Okay.
We're ready to go to work.
All right, so where do you guys want to start in terms of putting this down?
Well, the first thing we needed to do is get a parallel line off the house and transfer it out here because we want to make sure that our decking ends up even when it hits the house. We don't want to have a tapered piece at the end.
So you're going to start out there and work your way back in.
Exactly.
Okay.
We're going to use these blind clips right here. We're going to place them on the line so we can push our board into that, which is going to hold the edge of the deck from coming up. Okay, now the clips are in. We'll take the board, push them into that, and that will hold it. All right, that's our first board on that side. So now we can start installing the clips on this side of the board.
All right, here's the next one.
All right, that looks
So guys, you have left the front edge exposed. I presume you've got some
Right
sort of
there?
a trim piece, or?
Yeah, we're going to actually picture frame the outside perimeter. So what I mean by that, we're going to use a different board. You know, this, the ones that we just put down have a slot in them, and that's for the fasteners. Well, this one doesn't have a slot on either side.
Ah, hence that hidden fastener that you
So
started with.
when we lay it on the outside of the deck, like over there, you're not going to see a slot.
Gotcha.
We're also going to miter this corner and return to follow the angle of the deck all the way up. So what we'll have to do, this will come around like that. Once we miter this corner, we'll cut all these boards afterwards.
Gone, 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 gone.
Right, and then we'll have a nice border that runs straight up following the angle of the deck.
And so, Charlie, you guys are setting screws in here 3-4 courses deep, but you're not actually setting them down yet.
No, we're not. They made this nice tool, has a little cam system on it. To take that one over there, and you put it right on the sleeper or a joist. You put it on, you tighten it up, and it allows you to put pressure on all those boards right to the, look at that, right?
We do 4 or 5 rows at a time. Then we take this attachment right here that we put on any drill, and we take it over, stand on the deck, put it over the screw, and then we just screw down.
No way.
Yeah.
So you don't have to bend over
I like
at
that
all.
part. Yeah.
Cool.
Yep.
Okay. So now just, I guess what, just repeat the process and keep working back?
Yeah, about 50, 60 more times.
Yeah.
That's gonna be one good looking deck.
It's gonna be nice.
Nice job, guys.
Cold weather means it's time for insulation. Charlie's team laid down foam panels before pouring the concrete garage floor. The basement will be living space. Charlie has another trick for insulating that space.
They want this to be really a finished basement, so when we frame these, we keep it about an inch off the wall, so the foam goes right behind it.
Look at you right there. Okay, so no thermal bridging. I like that.
Perfect.
All right, well, I know they're ready to spray because I heard that truck going.
Yeah, we have to get out of here.
Hey, Adam. Nice to meet you.
Kevin, how you doing?
I'm doing all right. Thanks for helping us out today with this. So we don't often see the back of the truck, but we sort of get the idea, right? This A part, B part, and mix. But you have brought us a new formula?
Yeah. So recently, a lot of states across the country have adopted a new legislation that requires a brand new blowing agent.
And so what exactly does the blowing agent do for us?
It actually creates the cells. So
Yes.
it's the part of the chemistry that actually makes those cells.
And close those cells, because they're closed, it gives us a higher R value.
Exactly right.
And so the blowing agent was sort of the problematic part of the foam in the past, right? Because it had environmental impacts?
That's correct, yeah. So the impact was in the global warming potential.
Okay. And what about cost? Do we pay a premium?
Well, it's tough to say right now with material constrictions and supply restraints, but there's a slight premium, absolutely.
Do we lose any of the performance?
No, the good news here is application basically the same, parameters. These guys, if they've been spraying for a while, they're not going to miss a beat.
Well, as you say, if the guys have been doing it for a while, your guys have, and so those guys are really good. Most people don't appreciate that they're real skilled technicians.
No, you're absolutely right. They're worth their weight in gold.
So we just heard from Charlie how he set our stud wall off of the foundation. You guys like that detail?
Yeah, we love that. I mean, it's one of the more effective places to use spray foam in our opinion in Climate Zone 5, where we are with a lot of finished basements. That inch separation really allows for closed cell spray foam to shine. Its characteristics at an inch, it gives you both a type 2 vapor barrier as well as an air barrier. And it allows it to be a continuous insulation behind the wood frame wall.
All right, well, he's moving along. He's getting to the end there. So good information. Appreciate the help.
My pleasure, Kevin.
Thanks, Adam. Richard, it's cold outside. People are happy you're here.
Yeah, it was 36 last night, so people saying, how are we going to heat this building? So I thought we'd take a few minutes just to review it. First of all, as a heating pro, you start with a heat loss, heat gain calculation. And that means you look at the R value of the building, how much heat is going to leave through the building on the coldest day of the year, and you have to calculate a total. Same thing on the cooling side for the hottest day of the year. Then the question is how do you then deliver the heat and cooling to the building? So I made this little mock-up, because we come up with the size of this building. So this is the basement, here's the first floor, living and dining room and kitchen down here, and this would be the top floor, often the sleep zones. So often, the way it gets zoned is underneath the roof would just be an air handler or a furnace, and it really zone it by system. That top floor unit would handle the bedroom sleep zones up here. In the basement, there'd be another air handler or furnace to upfeed the first floor, end of story. But it's different. This house is really interesting. Here's the facade from the street right here. And it's as if we took a conventional Cape house, peeled the roof off, and then pulled it, cut it in half, and pulled it apart.
Right.
Right? And then in between it, we put a beautiful family room right here.
So we kept the kids' bedrooms on one half,
Correct.
but then we put the adult bedrooms on the back
Correct.
half. and
With
in
no real way to
between-
convey. So when you look right here, here's the kids right here, here's the master over there. There's nothing in between all this, and we don't want to take away that beautiful peak right there.
And you don't want to install any soffits for
Right.
the ductwork. You want to keep this all open.
Right, so we're going to zone it unconventionally, this side versus that side. But here in the middle, look at this space.
I love this space.
Right, this space screams for one thing, in my opinion, that's radiant floor heating.
Right.
Okay, it's got all this glass right here. It has no space for ductwork right here, and you're going to be moving from kitchen to great room, and you want to have no air movement. So from a comfort standpoint, it's perfect. So we're going to go with the radiant system with tubing, and you put your finished floor over the top of it.
You love radiant because we don't need ducts, and when you have vaulted space like this, we
Right.
don't have the heat up here. We have it down where we
That's
want
right.
it.
And with radiant here, and radiant in the garage, radiant in the bathrooms, and some baseboard in the downstairs that we're going to tie back onto, it suggests that we're going to use hot water to also power these air handlers. We're going to have air handlers, 3 of these, in the building like this. Return air comes back here, comes through a filter. Here's an air conditioning coil to cool the air in the summer. This is actually for heating the air. It's a hydronic heating coil, so it doesn't have a burner in it. It actually has heated water that's going to come from the boiler to heat the building in the winter. That water will change according to how cold it is outside. Really smart blower, so the air will come up to this T, and they'll have 2 motorized dampers per air handler. We're going to have a total of 3 of these air handlers. The damper's pretty straightforward, low voltage. You can see the blade damper right here that opens and closes, holds tight. And then we're going to deliver air by small duct high velocity. So air can come out of the floor, out of the ceiling, or out of the high sidewall, just can't blow on people. Connections are pretty straightforward. They now click on, makes its connections here, makes a nice tight seal.
So now the thermostat is controlling these dampers right here, saying
right.
open up for more heat, close it down for
That's
less
right,
heat.
right.
And we get all that beautiful zoning,
Right.
and we get water as
Well,
our primary-
zoning, there's only less than 10% of American homes are zoned because it's so hard to wire and people get scared of it. They've figured out this system pretty good. Look at this here. These are the 4 wires. See the colors?
Yeah.
Same wires that the electrician's going to use for the thermostat. The connecting of the dampers is pretty amazing. You just have these telephone jack cords right here, so you plug that in right here. And this one includes one more thing, which is a bypass eliminator, which means you put this in the supply duct right here, and if not enough dampers are open, that it might make a little more noise, it'll open the other one proportional to keep it nice and quiet.
Very cool. All right, nice system. We are always glad to see you, by
Yes.
the way, but particularly
I gotta
now.
get back to work.
All right, thanks, Richard. The same year our project house was built, a company here in Reading, Pennsylvania started making stoves. And they were massive. Coal-fired, cast iron. And they were state-of-the-art for their day. And today, they make commercial-grade ranges and hoods for homeowners. And our homeowners are big fans. Eliza, good to see
Hey,
you.
Kevin, nice to see you.
So you
Thanks
guys,
for coming.
Oh, thanks for having us. You guys have been making stoves for a long time.
Yeah, since 1880, actually.
Wow.
And we've evolved since then. Eventually now to where we are today, which is restaurant quality ranges for the home chef.
Okay. So where do you guys start? Looks like it starts with material?
Yeah, so it all starts right here. Our stainless steel comes into the building. It's in a flat sheet here. And from there, we start to cut it and make it into a range. This is our laser cutting machine. Each sheet is in here for only a couple of minutes. Very quick, very precise process, and gives you a nice, even, clean cut.
Moving left and right, forward and back, so sort of an XY, like a CNC machine, except we
Yep.
got laser and steel.
Absolutely. Very, very precise. So here we are. We're in the forming part of the process, and we have a piece of metal, and it's in a flat shape, and obviously we need it to get formed into a part that looks like this.
Cool, look at that.
So you can see the curves and the bends that we need to do to get it from the flat steel into a formed part.
So his job is, this is bending.
This is bending and forming, yep.
Forming, yep, okay.
Per a specific diagram.
Right. And is the computer dictating the sort of degree of the angle and all of that, or is it?
It absolutely is. You can see this this operator is very skilled, though.
He has
so
looked at the computer once.
yeah, he knows what he's doing. So we have our formed part. In this case, it's a control panel. Sits right on the front of the range.
So the knobs would attach to
Yeah,
this.
exactly. But we need to attach these two end caps to the piece to get it to be a fully formed piece.
So welding station.
Yep, so we're doing some TIG welding. This is all by hand. Very skilled welders here doing this process. A lot of great skill here. Now we have to polish it because the welding leaves a mark, right, that doesn't look very pretty.
So you've got some air tools. Looks like a ton of mini belt sander.
Yep, it's a sander, and when she's finished with that, she's going to use a lighter one to really polish it and make it really blend. That's the goal.
So we not just want to make it smooth, obviously, but you also want to try to get this finish close
to match
to this
that
finish.
Exactly.
Wow.
So here we are in our powder coating area. First, a part will come in and we need to wash it and get it ready for the process. And then we dry it. And then it goes into a powder paint booth. And the part hangs down actually on a negative charge. And the powder paint is positively charged. So when the operator sprays it, it adheres very, very cleanly and strongly and perfectly to the part. We're painting a color called light green. It's RAL 6027, one of the thousands of colors that are available. We even offer custom color matches where we can match to a paint color, a vase, a plate, literally anything you want. And then finally it goes into a 400-degree oven where it cures for, say, about 10 to 12 minutes.
Right, and once it cools off to where?
Ready to be assembled. This is a 60-inch range.
This is a 10 burners.
Yes, and you're seeing anywhere from 25,000 BTUs, and they're capable of simmering all the way down to 130 degrees.
Right.
So John over here is taking our burners. They're obviously hooked up to gas, and he's fine-tuning them to be very precise. So when it arrives in the homeowner's home, it works perfectly. So here we have a fully completed range for your project.
Look
We've got
at
6
this.
burners, a griddle.
What a monster.
They're gonna
this
love
is.
the power that they're gonna get from the range.
And 2 ovens in the front.
2 ovens. One even fits a full-size sheet pan.
Nice. And so custom color, which we asked you for.
Yep. It's called blue-gray, RAL 5008, with a beautiful brushed brass trim.
So we've got blue cabinets going in the island, so that's a nice match right
Yeah.
there. And this is a ton of BTUs for our homeowners.
Yes, they are gonna love cooking up a storm.
All right. Well, I love the tour, Eliza. Thank you very much.
Thank you so much for coming.
Appreciate it. Megan and Lincoln would like a solar system on the house, hopefully something big enough to power most of the home. They also don't want to see it from the street to preserve that original Cape look. So the challenge is how do you hide a big system on this home? Well, helping us with that today is Tim Sanborn. Tim, nice to meet you.
Good morning. What a beautiful solar day, Kevin.
That's the way you guys think, isn't it?
Oh, we love it. We love the sun.
So how big is this system that our homeowners have asked for?
We're going to put up 20 panels spread around the roof. They're 400-watt panels,
Yep.
so it's an 8 kW system, 8,000 kilowatts. It's going to produce about 10,000, 11,000 kilowatt hours annually for the homeowners.
Okay, and then in terms of power generation, how much of this home, what percentage of this home's power do you think these things are going to produce?
Most days we'll be able to give them just under 11,000 kilowatt hours on an annual basis to power on a daily basis most of the electronics in the house.
That's a big system on a big house.
Yes, it is.
So the real question is, where are you going to hide 20 of these panels if you can't use that front roof?
That's been a challenge, and is a challenge in every home. Can we go up on the roof and take a peek?
Yeah, sure.
One of the enhancements of solar over the years, Kevin, has been more aesthetically pleasing.
Yeah.
So you don't see any white lines anymore. You don't see any metal on the frame. It's a beautiful all-black system.
Hopefully it's just going to make it sort of blend into the roof line, not as noticeable.
Exactly.
And then in terms of efficiency, when you go to all black, I don't know, does that help or hurt the efficiency? And what efficiency are we at these days?
It's 20% efficient. What that means is 20% of the sunlight that hits the panel is going to turn into solar power.
So 20% probably doesn't impress a lot of people when they first hear it, but we've been putting putting these things up for years. And not that long ago, these things were 15, 17% efficient, so that's a pretty big jump.
That's where solar has gotten improvement over the years. It's gotten aesthetically more pleasing, but it also has gotten much more robust in terms of electricity power.
So I'm looking at, well, a lot fewer than 20 panels. You got more to go up. So where are the rest of the panels going?
We're going on that other roof over there.
So
we're going to
wait.
go 11 over there, 11 panels.
That looks like it's facing the street.
That is, but you won't see it from the street because the pitch is so slight.
Oh, okay. So that's how you hide them all in here.
That's correct. And we meet the homeowner's expectation of give me the best productivity and give me something that's aesthetically pleasing to the house.
And in this case, give me almost enough power to run the whole house.
That's exactly
throughout
correct.
the course of the year.
That is indeed correct.
And eventually, everything gets pushed down to the basement.
Yep.
Via these wires.
That is correct.
And we've even got a battery system going in.
We do have a battery system going in.
I want to take a look at that one. Hey, Sam.
Hey, Kevin.
So you are the engineer that designed the system for us?
I am.
This is the brains right here?
This is the brain, so this is the inverter. The solar power comes up from the panels that you saw on the roof down through this, and it can either go straight into the battery to charge the battery, or it can go convert to AC and go into your home.
Okay, well, battery is relatively new for us, so this is what interests me here.
Yeah, so that's a battery cabinet. You can pop that off.
Okay, thank you. I'm gonna see what's in there.
Yeah, exactly. So these are the individual battery modules. It looks like 2, but there's actually 4 stacked right there.
So what, you've got 2 and 2?
2 and 2, and then you can see there's a little bay for 2 more if you wanted to upgrade.
And in terms of capacity or load, however you guys talk about it, what is this providing?
Well, there's 2 things. You talk about energy, the capacity of energy. So this is 12 kilowatt hours of energy, and it also provides power, 5 kilowatts of instantaneous power.
So roughly this thing, if it was drawing all it could, those 5 kilowatts, it goes for about 2.5 hours or so?
Yeah, if you wanted to power this entire house, which would be a lot, you'd drain the battery pretty quick.
Right.
So what we like to do is set up a backup load panel or an
Sure.
essential load panel. So you take your bare essentials, what you need, boiler, a fridge, lights, probably the internet for most people.
Definitely the internet. The kids will
Absolutely.
kill you otherwise.
Absolutely, yeah. So if we try to keep that essential load panel at the bare minimum, we always aim to try to back up the house for around 24 hours.
Okay, that's very cool. And these days, they're super smart, right? You've got a lot of control.
Yeah, so you can set the controls on an app. The system all speaks with each other from the rooftop down to the battery. Or I like the system because it has an interface right there. Even if the internet's down, we can still back up the router, but the cable might be out. So if you don't have that, you can come and use this interface.
Beautiful. All right, well, like I said, solar has come a long way, and this is relatively new for us, so thanks very much for that.
My pleasure.
All right, well, from this point forward, it is a race to the finish, and that means a lot of interior work still has to be done to get this house ready for our homeowners. So until then, I'm Kevin O'Connor for This Old House here in Concord, Massachusetts. Next time on This Old House, our project is awash in craftspeople as finishing touches are checked off the list.